A pretty cool thing that C++ supports is function overloading. And function overloading shows up in a lot of ways in a lot of context in our C++ programs. So function overloading just refers to the general idea that different functions that have different implementations are allowed to have the same name. This is very different from C code, which every function has to have a unique name. But now we're going to say two functions can have the same name provided they have different argument lists. So for example, let's say I wanted a swap function and I wanted to be able to swap two variables in memory, their content. Like I want to swap integer A and integer B. But then I realized I don't just need to swap integers, I also need to swap doubles. So what I could do is write another swap function, give it the same name because it does the same thing, but change the arguments to be doubles. And the really cool thing about that is that C++ allows me to do that. And then I don't have to remember multiple function names. I just can remember that I have a swap function and I can use it. This is really useful when you need to express the same idea, but in multiple different ways. You can just use the same function name. Whoops, sorry guys. Okay, so here's my implementation of these two swap functions. So I have swap that takes integer pointer A and integer pointer B, and using some temporary variable, I swap the contents of the locations they're pointing to. And then I do the exact same code using doubles. So the code works exactly the same way, just different types. All right, and then down here in main, I get an X and Y from the input, and then I call my swap function to swap them around, and then I can print them back out and show that they're swapped. Now, the really neat thing about this code is the compiler figures out which function is best to call. It knows that it's being passed a pointer to integer X and a pointer to being passed two integer pointers. And so it looks at the two versions of swap that it has, and it says, okay, which version of swap is the best one to call? Well, obviously, the version of swap that takes two integer pointers is better for this case than the version of swap that takes two double pointers. So it's going to call the first implementation of swap here. Function overloading can be used in a lot of different contexts. Used on class member functions. It can be used on constructors, right? So we could have multiple constructors in a class that take slightly different arguments, so that we could construct an object in different ways. And it can also work on any ordinary function we have in our program. We can apply function overloading anywhere we declare functions. Something to know, though, is that the argument lists have to be different on these overloaded functions. You can have different return types, but different return types alone are not enough to differentiate overloaded functions. So for example, if I wanted a function that returned integer 0 and another function that returned double 0, but they took no arguments, this would be illegal, and the C++ compiler would complain because there's no difference in their arguments, and the compiler wouldn't be sure which one it should call. It'd be confused. The programmer want me to call integer 0 or double 0. And you might say maybe it could tell based on the return type. But the problem is the C language and the C++ language inherits from C in this regard is that it's allowed to perform automatic conversions between some types, int and double being one example, right? So it can automatically convert an int to a double. And so then it gets really confused. It's like, well, I could call the version that returns int and then convert it to double, or I could just call the version that returns a double, right? And so, those look like really similar options to the compiler, and it just throws an error. It gives up. So we want to avoid problems like that. There has to be a clear difference in the argument lists. One really easy way to create a difference in argument list is to have a different number of arguments. Okay, and another way is to have the same number of arguments, but different types of arguments. The compiler has heuristics built into it to help it decide which function is the correct one to call. When there are multiple functions with the same name, in other words, when there's an overloaded function, the compiler has to pick one, and it picks one using what are called best fit heuristics. Here's an example of what a best fit heuristic may be like. Inside the compiler, it would have some logic that says, a function that has the same number of arguments as the one being called and needs the fewest type conversions, right? And just to review again, a type conversion means changing something like an int to a double, or a character to an int, or even class X to class Y. We haven't talked about how to do class to class, but that can also happen. So look at this. Which function should the compiler pick? Let's pretend like we have these four. Let's pretend like we have these declarations. So C and D, and they're each a little bit different. And now let's look at these 6 statements in a program. Which function is it going to call? Which compiler going to pick to call? But for the first one, it's going to pick A, because this call to F takes a single integer argument. And there are 2 functions over here that take a single argument. And the best match is the one that takes an integer, because that requires no type conversions. So it's going to call the A version. Okay, let's try the same logic out again on the next one. So this next F takes 2 integer arguments. Of my list of candidate functions, B and D take 2 arguments. But for D, I would have to convert both the arguments from int to double. There are 2 conversions. But for B, no conversion. So B is the best option. For 3, I'm passing in 2 doubles. Said D one already, good job. Yeah, it takes no conversions for me to call D and for the compiler to call D. So that's the one that's going to. Okay, for the next one, I pass in a 3 and a 4. Again, these are integers. You know they're integers because they don't have a decimal point at the end, or not in scientific notation. So they have to be integers. And the compiler, again, will say, oh, well, this has to be B. Now, you might say, but wait a minute. It's being stored into a double. And B doesn't return a double. B doesn't return a double. Only D returns a double. That's true. But the compiler basically ignores the return type when deciding what to call. It's only looking at the arguments. It interprets what's going to happen to the return value as a different situation, right? It's what happens after I get the result back. It has to do some manipulation. But which call it makes is only dependent on the arguments going in. Okay, now 5 takes a single argument. It's of type character. And so C is going to be the best choice here, right? Because to call A, it would have to do 1 type conversion. Okay, now this last one. I have the first argument is a double and the second argument is an int. Okay, so to call version B, it would have to do a conversion on the first argument, but not the second. And to call D, it would have to do a conversion on the second argument to int, but not the first argument. So which one's it going to call? They both have the same number of conversions needed, 1. Well, this is going to be a syntax error. And the compiler is going to say, I don't know which one to call. They both require me to do a conversion, and I don't know which one's better. And so your program's going to fail to compile here. It's a syntax error, and you'll get an error message at compile time because it can't decide which is best. So this is an example of where having maybe too many versions of your function is problematic. I mean, not only is it confusing for a programmer, like I'm not really sure as a programmer which one I would prefer, and it's confusing for the compiler because it doesn't quite know what to do. So, when it comes to overloading, it's nice to have this power, but be thoughtful about it. Use it sparingly so that programmers and the compiler doesn't struggle to know what's really intended and what's really best. Okay, so in summary, C++ allows different functions to have the same name, provided they have different argument lists. The compiler, at compile time, has to pick one of them based on the arguments provided and based on some internal built-in heuristics. Namely, the argument, it needs to have the same number of arguments, and it's going to pick the one that requires the fewest number of type conversions. And if there are multiple options with the same number of type conversions and arguments, the compiler is going to fail. Okay, too many overloaded functions with similar arguments can lead to confusion, both for the programmers and compilers, and so you want to avoid that if you can.